everyone, this is Maurizio, editor-in-chief of Power Electronics News. I am at PCIM and I have the pleasure to stay here with Matt Romig, business lead isolated gate drivers at Texas Instruments. Hi Matt, how are you?
I'm doing great.
So we are PCIM, so tell me about what Texas Instruments is showing, is introducing. What's news?
Okay. Yeah, so this is my first time here, so I just want to firstly say it's been really fun to be here and just see all the innovation, all the energy across the supply chain and locally here in Germany. It's been really exciting. So for TI specifically, in our booth, and this is our first time having a booth in a while here too, we are focused on high voltage, we're focused on electrification. We have a total of 6 focused demos, and the one that I'm representing is a 300 kilowatt traction inverter, which uses a couple of our newest chips. One is the UCC 5880, which we're just announcing this week, and another is an integrated isolated bias supply called UCC 14141.
So just talking about gate driver, how does gate driver strength affect the operation of power devices? And what are some of the key parameters that you need to take care selecting just when you are working in some projects, maybe talking about silicon or wide band gap?
Sure, I'm glad you asked about isolated gate drivers because actually we're finding more and more that the success of the power device, and particularly silicon carbide, is driven by the gate driver. So the gate driver is literally what makes the silicon carbide go and not go. It actuates the silicon carbide, it charges the gate, it's what turns it on and causes the current to flow. So we see the isolated gate driver as hand in hand with the success of silicon carbide, and we're very excited about silicon carbide as well. So specifically, a couple of the big features in the isolated gate driver, the UCC 5880, that stand out. One is the isolation. We never take that for granted. That's an essential feature because you've got high voltage, high power on one side of the system, and on the other side of the system, you've got people, and you've got sensitive, low voltage circuitry like the MCU. And so the isolated gate driver protects those things, which is essential. Functional safety is another important feature. So for an isolated gate driver to do what it needs to do in terms of making the silicon carbide and therefore the car go or not go, it needs to have a lot of diagnostics and protection. And so we talk about gate voltage monitoring, we talk about overcurrent protection, we talk about current sensing, temperature sensing, integrated, things like that, or just open pins that the customer can use to monitor what they would like to about the silicon carbide. And then the last big one that we talk about is efficiency. So a big feature in the UCC 5880 is the real-time variable gate drive strength, which allows the designer of the system to customize the gate strength based on the operating condition.
So talking about challenges in particular for the next application, so the next, also the current, electric vehicles, renewable energy, how are isolated gate drivers evolving to meet the next requirements of power electronics for EV and renewable energies?
Sure. So traction inverter and the electric vehicle motor is still very early. So I think there's still a lot of evolution and just shared innovation across the supply chain within traction inverter. So we talk about efficiency, we talk about solution size and power density, of course cost and supply chain and things like that are important as well. So firstly, within traction inverter, we're still very early, and part of the fun part about releasing a new product is getting to partner with designers and engineers and find out what they can do with it and then what we can do next, specifically within traction inverter. Outside of traction inverter, charging is a really important area. It's one of the biggest challenges that we hear about. Actually, I caught a ride share to the airport on Sunday. The driver was driving an electric vehicle, and so he had no idea I'm an engineer going to a trade show to talk about innovation in electric vehicles, but I was asking him what does he like, what does he not like, and he loves the speed, he loves the features, he loves the low maintenance, but the one complaint he had was the charging and the range. So that just reminded me that helping with efficiency and then helping with charging infrastructure, fast charging, location of charging, how you charge in the home, how you tie into the grid. All of those are very exciting. So isolated gate drivers specifically, silicon carbide is going into all those applications along with IGBTs today. The voltage is going up. So really a lot of the challenges are the same. Fundamentally, it's just about maybe what are the specific operating profiles or voltage and current profiles for those applications, where as we work with those engineers and those designers, we find out what specific features we need to put in the products for those.
So the next energy revolution will see not only wide band gap, like you said, in terms of silicon carbide and gallium nitride, but also technology about machine learning, for example, or artificial intelligence algorithm, because the grid should be smarter and smarter. Mm-hmm. So how do you see the next future among these technologies?
Mm-hmm. So I would say at a TI level, that's really a system challenge and ties in a lot of different components. And of course at TI, we like to play all through the supply chain, and we want to make sure we've got a solution wherever it's needed. So that gets really interesting as we partner with those in the industry who are driving maybe the software side and see how that translates back to the hardware side. Specifically with isolated gate drivers, I would say the biggest challenge will just continue to be energy efficiency, as we see, in the grid where the energy is coming from, and we talk about power conversion, where you've got to take energy that's generated somewhere. Maybe it's traditional generation, single point. Maybe it's distributed with solar, wind, things like that. But taking that power from where it's generated to a highly distributed, where it needs to be, doing that quickly, doing that efficiently, solutions that are the right size. So we continue to just be amazed by the innovation that our customers bring in, and then the opportunities that gives us to kind of cater our products towards that. So I think we see a lot of growth in that space as well. Sorry.
Thank you, Matt. Thanks a lot for your time. Enjoy PCIM.
You're very welcome. I'm really enjoying it.
Thank you, and stay tuned on to our channel, powerelectronicsnews.com, with the latest news. Thank you.